Welcome to my channel. In this video we are going to learn about the searching techniques. That is, there are two types of searching techniques in the data structures, that is linear search and binary search. Okay. So first of all we will see the linear search. So in the linear search we are going to search in an array in a linear manner or in a sequential manner. So here we are going to consider the unsorted list or unsorted array, and we are going to search the element in the unsorted array. Okay. So here the linear search is easy to write and efficient only for the short type of arrays, shorter arrays, but not for the longer arrays. Okay. So now we will see the algorithm. So we have taken the array of length 7, right? So 0 to 6. If array of I equals to element, so element is the element that is we are searching for in the array. So if the index matches with the element that user is searching, that user wants to search in the given array, then print found at the particular address location, that is the %d, I, that is the value in the array of I index. Okay, found equals to 1 and break the if condition here and come out of the loop. So if not found, then so we are going to print not found. Okay, so linear search is a simplest form of the searching technique, and it is also called as a sequential search. So remember one thing, that we are going to search in a unsorted list of elements. So next, coming to the binary search. Here the performance of linear search can be measured by counting the number of comparisons taken to find the key in the array of size n. Right? The average and worst came and the worst search times for the algorithm are both proportional to n, that is the big O of n. Okay. And here we are rarely using the linear search technique, and it is less efficient compared to the hash tables and binary search algorithm, and there is no need to sort the elements in the array. But in the case of the binary search technique, we need to sort the elements in the array. If you want to search an element, first of all we need to sort the particular array. So coming to the binary search, it is a efficient and optimal searching technique. So while searching the elements using this method, the most effective thing is that the elements in the array should be the sorted one. Okay. So an element which is to be searched in the given array is called key element, right? So we are going to call it as key element, that element that we want to search in the given array. Okay. So here this is the algorithm. So low is 0, that means the starting of the array, and high equals to n minus 1. So we are taking the length of the array length as 7. Okay. So high equals to n minus 1, that is 7 minus 1 is 6. So 0 to 6 is the array length. Here we are going to apply a formula, that is the low plus high by 2. Okay. So using the binary search technique, we are going to divide the given array into 2 subparts. Okay. So based on the middle key value. Okay. So based on the middle key value, we are going to divide the array into 2 subparts, that is the lower part and higher part. Okay. So let us see about this. How can we divide this? Okay. So we know that key is the element that we are searching in the array. So if key equals to a of m, a of mid, that means a of the middle value, so then the desired element is present in the list. So if key is less than a of m, so here a of m is the middle value, right? So a of middle value. Okay. So if the key value is less than the a of middle value, that means less than means this thing will come, right? So a of middle value. If the key value, that means that the value that we are searching for is less than the middle value, then so we are going to search in the lower part. If the key is greater than a of middle value, then we are going to search in the right sublist. Okay. So consider a list of elements stored in the array A as 10 to 70. Okay. So here the key element that we want to search is 60. So we are considering the key value as 60. Okay. So now to obtain the middle element, we will apply the formula, that is middle equals to low plus high by 2. So this is the given formula. Okay. So we know that low equals to 0 and high equals to n minus 1, that is 6. Okay. So 0 plus, so we are going to apply this formula here, that is 0 plus 6 by 2, that is 3. So now we found the middle element, right? So this is the formula to find the middle element. So we found the middle element, that is 3. So this is the middle element, and we are going to divide this array into 2 subparts. If the middle is not equals to the key element, then we are going to divide it into 2 parts, right? So first we will go into the algorithm here. Okay. So if the key equals to a of middle, right? So if key equals to a of middle, so what is the key value? 60. So is 60 equals to a of middle, that is 40. No, it is not equals to 40, right? So 60 is greater than 40. Okay, 60 is greater than 40. That means, so here there is a mismatch. So we have to divide the given array into 2 parts, right? So this is the lower part and the higher part. So we are going to divide it into 2 parts, right? So since the given key element is greater than the middle element, okay, so we will search in the right sublist first of all. Okay, so here key is greater than a of middle element, right? So key is greater than a of middle element. Okay, so what is the key value? 60 is greater than middle element, that is 40, right? So that's why we need to search in the right sublist, right? So it says the right sublist. So here the right sublist is 50, 60 and 70. Okay. So now we will again divide the list and check the middle element. So now we will again apply the same formula, that is the middle equals to low plus high by 2. So low plus high by 2, that is the 4 plus 6 by 2, that is 10 by 2, that is 5, right? So the 5 is the middle element. So now first of all let us check whether the key matches the middle element or not. If key equals to a of middle, so we are searching that whether the key is equals to a of middle or not. So 60 equals to 60, right? So here there is a match and the key element is found. So it will print that found at %d, that is the location 5, and it will print the value. Okay. So based on this algorithm we are going to divide. So first of all we have to find the middle value of the binaries of the given array. So after finding the middle value, okay, we have to compare whether the key value is equals to middle value or not. So if the key value is not equals to middle value, we have to divide the given array into 2 parts, that is the lower sublist and left sublist and the right sublist. Okay, so how we will divide the sublist into 2 parts, left and right means, so here if key is less than a of middle, okay, so if the key is less than a of middle, then high equals to middle minus 1. So middle minus 1. Okay. So we are going to divide this into 2 parts. Right. So what is the middle minus 1? 2. So 0 to 2. So this is the particular value. So this is a particular sublist. And here if the key is greater than middle element, then we have to search in the right sublist. So the basic operation in binary search is comparison of the search key, that is the element that we want to search in the array. To analyze efficiency of the binary search, we must count the number of times the search key gets compared with the array elements. The comparison is a 3-way comparison, right? So first of all we have to find the middle element and then check if the middle element is not found, divide the given array into 2 subparts and check check for the key element in the two subparts. Okay. So now let us know some of the advantages and disadvantages of the binary search algorithm. So advantage of binary search is it is an optimal and efficient searching technique which we can search the desired element very efficiently. And the drawback here is the array must be sorted. So that is the only drawback here. And applications of binary search are it is an efficient searching technique and use it to search the desired record from the database and to solve the nonlinear equations with one unknown. This method is used. Okay. So here the best case of the binary search algorithm is big O of 1. So big O of 1 is the best case of the searching technique. That means if the key value is the A of middle value, so at the first search only, so we are going to find the element. We are going to find the key element. So that is the big O of 1. That is the best case of the binary search technique. And average case and worst case of the binary search technique is big O of log n. That means so we have to divide. So if the key value is not equals to middle element, then we have to divide the given array into two parts, right? So and again, so we have to divide the sublist into two parts, so on until we find the key value. So that division of the given array into sublist is called as a sublist occurs in average and worst case. So the worst case is we cannot divide the array further. So that is the worst case. At that time only we are going to find the key element, right? So that is the worst case. So big O of log n is the average and worst case. That means we will keep on dividing the given array, okay, until we find the key element. So this is about the linear and binary search techniques. Thanks for watching my video. Please do like, share and subscribe to my channel. Thank you.